Oh, that's, man, we don't want to do timers. We just did timers. Here we have counter instructions. They look very similar to timers, okay, except they're counting. Guess what? And I've seen there's some oddball PLCs, they don't have timers. You have a pulse bit. You got a 1 second pulse, and you program that pulse bit to count. And then you make you turn your counter into a timer if you pulsed it every 1 second, right? Same deal. So counters must be reset because it doesn't know when you're done counting. You're going to have to reset it. Okay? They can be programmed to count up and count down, or do a count up and count down pair. So here's our up counter. And let's simply look at it. Easiest way to look at that is I'll just program it, and you'll instantly see how it works, right? You won't have any questions for me. I'll come over here. I'm going to grab a counter, left click, hold. I'm going to drag it off. And we're going to count to 5. How are we going to count? We're going to put in a count button. Here we go. We're counting up. We've reached our part count of 5. Guess what? All that preset and accumulated value does is to tell the done bit to come on. It'll keep counting until it wraps around, which is 32,768. Wrap around. And that's it. That's count up. That's it. That's it. If I want to add a reset function,
you said a reset function?
Yep, you've got to reset them. They don't do any good without a reset.
So they actually have a reset bit?
Yep, you have to add a reset instruction and give it the same address as the counter.
Will it always pop up the same address as the counter, or will you have to modify it?
You'll have to put it in there. You see, I drug it off the counter and dropped it in.
Cameron, every time you put a bit in, how much of your memory are you using up? Because you're putting in lots of bits in there, you know.
We got plenty, trust me. We're using 1 bit is almost nothing.
Like 16 spots on a.
Yeah.
Right.
You can see how much memory you have available to you. Their processor status, memory. Where's that? Maybe it's controller property somewhere. If you hadn't asked me, I probably could have told you.
Well, I just, that even them counters are taking up space, right?
Yeah.
Every time it counts, it's taking up more space.
Yeah.
When you delete that, does that take it out of your memory?
Yeah. Yeah. Well, it doesn't take it out. I'll see if I can figure that out. I can't remember where it's at right now. It doesn't take it out until you get rid of the data file. The data files take up memory. And I made a data file. That makes sense?
No, but, okay.
Well, these data files, there's a certain amount of memory that's going to be taken up. But if I go here, see the elements? If I add more elements, I'm going to take up more memory. Right now I have 10 timers. That makes sense?
That makes a little more sense, yes.
Yeah. You're reserving a spot in the memory for that stuff when you add the data files. Then if you don't use it, it's still going to reserve a spot. It doesn't matter. Here's our counter file we can look at. There's a count up bit. It's true whenever the count up counter instruction is true. Now remember, this same data file works for count up and count down. There's such thing as a retentive counter. No, they're all retentive. Yeah. Got to use a reset. So here we have a count up. It's whenever the count up instruction is true. Count down, if I programmed it as a countdown timer, it's just going to count down from 10, like launching a rocket. 10, 9, 8. Count up is 1, 2, 3. Then we're all going to have a done bit that comes on when the accumulated value is equal to or greater than the preset value. Now, one thing I want to point out before is the timer. The timer, when the logic to the left of it was true, it began to time, right? Here, with a counter, we're looking for a pulse function. If the logic to the left of it stays true, it's only going to count one time until it goes false to true. We're looking for a false to true transition. Right here, false to true. See, it only counted one time. One time. So we're looking for a false to true transition on all of this. There is an overflow bit. Here's the number I told you, 32,767. I may have lied and said 32,768 because I always get them mixed up. Positive or negative. Once it gets to the overflow, once it counts all the way, it'll wrap around. Or you could count to 1,000, increment 1,000 part counter and say that counter is how many. I've run 2,000 parts today. And then you could add the 2,000 plus the current count and say, I've run 2,338.
Why will the counter only go to 32,000?
That's the limit of the 16-bit binary number we can.
Why does it stop there? Why does it not go back to 0?
That's just the way they made it. I mean, it counts to its limit and then just rolls over, just like the odometer on your car.
Does it? Okay, a counter. We used to have something called a batch counter.
Yeah.
And the batch counter would go to 32,600, 767 or something like that. I think it was that. And it just stopped. It wouldn't go any further. It wouldn't count anymore.
Yeah, well, that's because it's poor programming.
Okay.
It wasn't programmed correctly. If it was programmed correctly, there'd be a way to reset it or it would have cycled over. It happens. They didn't give you a reset button, then.
No, they didn't want us to be able to reset that.
Well, and they wasn't poor program. That's why they did it on purpose. Somebody wrote that number down, I guess. But yeah, that's the limit on counters. Now, when we do a CLX, I think the part count on it's 1 million plus with a 32-bit double integer number. So I don't worry about it then. It says the update accumulator bit used with in conjunction of a high-speed counter. We got preset and accumulated value word. Are you with me? When's the timer done? I mean, when's the counter done?
When it gets to its preset.
When the preset equals the accumulated value. When's the timer done? When the preset equals the accumulated value. Okay. So we've looked at these. We've seen where they're at in the toolbar right here. All right. There is a high-speed counter. Counts high-speed pulses from a high-speed input. A couple ways you can do that. You could just let the high-speed counter do its thing and just pull the number out every once in a while. Usually what I do. Here this runs for 10 seconds and turns the motor off. Okay, or it runs 10 times. You can run the motor 10 times and it's going to shut off until you hit the reset button. So here we can go. Here we're counting parts and packages. We're counting the cans going into the package. And then we're counting the package coming out of the shrink wrap machine. Talks about one-shot bits. We're going to get into those in a little bit. OSR bits. Now I want you to look at this. One-shot rising bits, you assign a binary address. They get you in trouble. But when you turn them on, it just makes whatever's to the right of it happen one scan. Are you with me? One scan. That's all it does. And then the logic to the left of it has to go false and then true again before it happens. So let's look at our programming out of one shot. Here we have part count reset. What happens if I hold this, flip this reset? Doesn't count anymore, right? You with me? Not working. I'm holding it reset. I'm going to drop an OSR bit in there. I'm going to grab a bit and drop it in there. I don't care what it is. By the way, you don't have this in the free version of that software, but in the paid version, see all these binary bits in the data file? If I click usage, the ones with an X are already used in my program. Are you with me? If I want to know where that bit is, I can right click on it and go find all. And it's going to tell me where I'm using it, and I can double click on it and it will take me there. So you can find about anything in a program by right click, find all. It's going to tell you where it's all being used. Anyway, that's a little, I just thought about that, so I was going to show it. Notice now that the OSR is fired one time and reset. Look here. Have to turn it off. And it resets one time. See? So it's a one shot. It's a one shot deal. It basically sets up a pulse. You take a static on or static off, and now you set it to a pulse trigger. Here they're using it to rapidly freeze a counter. They're yanking the data out because it's really changing fast, or a timer. This is doing a timer. We yank the data out. put it to hold the register, and we can see the current line speed every time they push a button. How you want to do it, but it's an example. Let's look at a down counter. It's exactly the same, except it counts down. Okay. Notice we're using the CD bit right now. It's working instead of the CU bit. The reason they have those extra bits is because these timers, they only have one data type. And depending on what instruction we add, they can have a space for the data. All right. Plus, we can use a count up, down, count down pair. So let's look at this. Let's change that to a countdown. Here we go. What's the next accumulated value when I flip the switch?
Accumulated.
Yeah, what's accumulator going to go to when I flip the part sensor?
When you go to 5,
Well, no, we went count down. It's going to go back.
It's going to go 2.
Yep. I hit the reset button. I'm sorry. I'm counting negative now. That was my fault because I didn't mean to hit the reset switch. We'll put it back the way it was. So we'll say if I don't hit the reset, it should go 2. There we go. Hit the reset switch.
And it only goes down to what? 10?
Negative 32,368.
You got to reset again, didn't you?
Yeah. You want to see what happens when it reaches the limit?
No.
Let's type in negative 32,765. I'll watch it go a little bit. Oops, wrong button. Let's do that again. Let's try, all right, 7. There we go. We're going down. Just rolls over.
All that matters is you lost your negative number. It went to 32.
Yeah, it rolls over. Right click, go to data table, we'll bring up our data. See this right here? That underflow bit came on. So technically speaking, when the underflow bit comes on, you could add 32,768 and get a current number and move it into a floating point value. Okay. Since it's it's spun over bit. It won't tell you when it spins over a second time. Only one bit. You with me? It's a rollover bit.
That number 32,767 only applied to RS Logix 500?
No, it applies to any 16-bit signed integer. Remember, we have a sign, the last bit's a signed bit. It applies to any 16-bit signed integer. Here we have up-down counters. That's where we're at. So let's do an up-down counter, which is actually pretty handy. So what we got here, anybody with a kid, remember playing with that game? Remember the barrel of monkeys where you have the big plastic barrel and you have all the little monkeys and you hang them on the lampshade, whatever, and you start stacking them together and see how many you can hang down? So we got a part count. We got a barrel we're filling up with parts. We're going to need this in a to change this out. Let's change the name of this to end bin. So we got a part sensor into the bin. We'll just reset that. We'll go, our bin can only hold 5 parts. It's a small bin or a big part, depending on how you want to look at it. Let's reset. So here we got 1 part goes in the bin. Bin's full. I know that because my done bit came on. Okay, and that the preset equals accumulated. So now I'm going to start emptying the bin. Maybe it's some kind of bath or oil bath or whatever. Guess what? My bin's empty. So now it's okay to fill back up the bin. Maybe I fill up the bin, wait 30 seconds to let it soak in the oil, and then I empty the bin and I repeat. We use them in pairs. Do you see that? Notice, here's the deal. You want to use a count up, count down pair. They have the same address. Do you see that? So that's a count up and count down pair. And we already talked about that. Cascading counters. Talks about extending the count. I already talked about that, how we can use one counter to fire another counter and use a stand-in part. Basically, if you got a count larger than 32,768, you're going to have to do this in a 16-bit processor like we're in. Here we have, when this is done, this counts to 500. When it goes done, this counts to 500. So, what's my total part count here if this one equals accumulated value of 2? It's 1,000. Got 2 500 parts. Say this is 500. This one counts to 500 right here. And we toggle one in here. So now I have 500 parts. This counts to 500, and then I toggle another one. Now we got 1,000 parts. Here's a clock. If you wanted to, if you have an SLC, I would just read the clock bit because it has a date and time. I wouldn't use that. I just read the clock. You can program stuff to happen days or weeks later using the clock function. Here we have a incremental encoder. I get a pulse. Maybe I get a pulse every inch. So if I have a part and I want to know how far it traveled or how long it is, I can measure a part, right? If I have a part, well, to the nearest inch. Here's our wood cutter. Parts come through here on an encoder. There'll be a sensor here to see the start of the board. Are you with me? and we'll start the current count. We'll reset it, and then we'll count how far it travels until the sensor does not see the board, or the sensor travels. Maybe we want to cut it off every 8 foot. So it'll see the start of the board, start the counter off the pulse, and then it'll pulse 8 feet, and then cut the board, and then we get 8-foot boards. Make sense? You can put them together. You can do whatever you want to. As far as a PLC program, you're not as limited. Here's 2 timers and then a count up. What's the motor lockout program? I don't know why you're doing it. Product rate flow. Here, this is pretty handy. You want to know your parts per minute? Well, count your parts per minute for 60 seconds and then display the number. Reset, count your parts again for 60 seconds and then display the number, the accumulated value. And then you would know your parts per minute. It would only update once a minute though. If you wanted it to update faster, count the parts per minute for 30 seconds and divide by 2. Depending on how many parts you got. It's not as accurate. But. Here they're using a timer. They're basically turning this counter into a timer.
You said divide by 2 or multiply by 2?
Multiply by 2. That's my fault. Yeah. Sorry.
I'm just trying to understand.
Yeah. There. That's what you all been waiting for, isn't it?